Have you ever wondered why February has 29 days every 4 years? That's our leap year conundrum, a fascinating quirk of our calendar that has mystified and intrigued for centuries. A leap year, as we commonly understand it, is a year with an extra day. That's right, an additional 24 hours tacked onto the shortest month of the year, February, making it a bit less short every 4 years. But why? What purpose does this extra day serve? And why is it a quadrennial event? The concept of a leap year is not a random, whimsical addition to our calendar. It's a meticulous adjustment, a calculated correction made to keep our human-made system of time in sync with the celestial rhythm of the universe. The Earth doesn't orbit the Sun in a neat 365 days, but approximately 365 and a quarter days. Over time, this fractional excess adds up, and every 4 years, we need an extra day to realign our calendar with the cosmos. But it's not as simple as adding a day every 4 years. Even that wouldn't keep us perfectly in tune with the universe's timekeeper. The Earth's journey around the Sun is slightly less than 365 and a quarter days. It's about 365.2422 days, to be precise. As you can imagine, this discrepancy led to a few headaches for those who first tried to reconcile our calendar with celestial time. It's a puzzle that required a blend of astronomy, mathematics, and a fair bit of trial and error. The leap year is a testament to our human need for order and accuracy. It's a fascinating example of how we've learned to dance with the universe, matching our measure of time to the cosmic beat. Intriguing, isn't it? Let's delve deeper into this fascinating occurrence. Our leap year journey begins centuries ago in ancient Rome. Picture a time where chariots ruled the roads and togas were the height of fashion. In the midst of this bustling civilization, the Romans were grappling with a calendar conundrum. Their lunar-based calendar was falling out of sync with the solar year, causing seasonal confusion. To solve this, Julius Caesar, with the help of the astronomer Sosigenes of Alexandria, introduced the Julian calendar in 46 BC. This new calendar was solar-based, comprising of 365 and a quarter days. To accommodate this quarter day, an extra day was added every 4 years, giving birth to the leap year. However, this system wasn't flawless. The actual solar year is approximately 365.2422 days, slightly less than the Julian calendar accounted for. So, over centuries, this tiny discrepancy added up, causing the calendar to drift significantly from the solar year. Enter Pope Gregory XIII in the late 16th century. To correct the drift, he introduced a new system, known as the Gregorian Calendar, which we still use today. The Gregorian calendar refined the leap year rules, stipulating that while most years divisible by 4 would be leap years, those divisible by 100 would not, unless they were also divisible by 400. This added a level of precision that brought the calendar year more in line with the solar year. From ancient Rome to the Vatican, leap years have been a solution to a celestial puzzle, a way to keep our human-made time in harmony with the universe's rhythm. The leap year is a testament to our ancestors' ingenuity and a reminder that our timekeeping systems are intrinsically tied to the cosmos. So, the Romans were the leap year pioneers, but there's more to the story. Now, let's take a leap into the world of astronomy to further our understanding. The primary reason for the existence of leap years can be traced back to the cosmos. Our planet Earth does not orbit the Sun in exactly 365 days. No, it takes about 365 days and a quarter, or more precisely, 365.24 days. This might seem like a trivial difference, but over time, these extra fractions of a day start to add up. Imagine, if we didn't account for these extra 0.24 days, our calendar would be off by about 1 day every 4 years. In a century, we'd be out of sync by nearly 25 days. Now, that would certainly wreak havoc with seasons and our understanding of time. So, to keep our calendar year synchronized with the solar year, we add an extra day, the 29th of February, every 4 years. This year, known as a leap year, consists of 366 days. This extra day essentially compensates for the 4 quarters of a day we missed in the previous 3 years. But wait, if you're a math enthusiast, you might notice a tiny discrepancy. If we add a day every 4 years to account for the extra 0.24 days, we are in fact overcorrecting by adding an extra 0.01 days each year. Over 400 years, this would result in an excess of about 3 days. To correct this, the Gregorian calendar, which we follow today, omits 3 leap years every 400 years. So, when you think about it, the concept of leap years isn't just about adding an extra day to February every 4 years. It's a beautiful blend of astronomy and mathematics, designed to keep our human-made system of time in harmony with the celestial dance of our planet around the sun. So it's all about keeping our calendars in sync with our journey around the sun. But how did we decide on adding an extra day every 4 years? Well, the answer lies in the heart of mathematics and a keen observation of the celestial bodies. Let's imagine a year as a perfect circle. Now, if a year was exactly 365 days, our circle would be complete, without any overlap or gap. But that's not the case. It takes our planet approximately 365¼ days to complete a full orbit around the sun. That's about 6 hours longer than our typical 365-day year. Now, if we ignored these additional 6 hours year after year, they would start to add up. After 4 years, those extra 6 hours would accumulate to approximately 24 hours, or 1 full day. This might not sound like much, but over centuries, this discrepancy would cause significant shifts in our calendar. That's where the concept of a leap year comes in. By adding an extra day every 4 years, we effectively pay back the time debt that we borrow from the universe each year. This keeps our calendar in sync with the Earth's actual position in its orbit around the sun, but we're not done yet. There's a little more to this mathematical marvel. You see, the Earth's orbit isn't exactly 365¼ days. It's about 11 minutes short of that. So, if we added a leap day every 4 years without fail, over time, we would overcorrect the discrepancy and end up with extra days. To counter this, the Gregorian calendar, which we use today, introduces a further rule. It states that a year is only a leap year if it is divisible by 4, but years divisible by 100 are not leap years, unless they are also divisible by 400. This complex system of checks and balances ensures our calendar remains remarkably accurate. With an error of only about 1 day every 8,000 years, it seems our ancestors were pretty good at math, doesn't it? An extra day every 4 years may not seem much, but it has some interesting societal impacts. Let's start with legal issues. In many countries, laws have been formulated to deal with the unique challenges of February 29th. For instance, in some places, if your driver's license expires on a leap day, it is deemed to expire on the last day of February in non-leap years. Imagine the confusion without such a provision. A leap year also has implications for cultural traditions. In Ireland, for example, there's an old tradition called Bachelor's Day where women propose to men on the 29th of February. This practice has been attributed to St. Bridget, who supposedly struck a deal with St. Patrick, allowing women this privilege every leap year. Though not universally observed, it adds a fun twist to the leap year narrative. Now let's talk birthdays. For those born on February 29th, birthdays can be a bit tricky. Do they celebrate on the 28th of February or the 1st of March in non-leap years? There's no universal answer to this, and it often boils down to personal preference. Some leaplings, as they're affectionately known, revel in the uniqueness of their birth date and celebrate only every 4 years, making every birthday a grand occasion. On a broader scale, the leap year serves as a reminder of our ongoing efforts to understand and align with the universe's rhythms. It's a testament to human ingenuity, as we've devised ways to account for the Earth's imperfect orbit, to keep our calendars and lives in sync. Moreover, the leap year subtly underscores the importance of time in our lives. It's a day that prompts us to consider how we use our time and perhaps to appreciate the extra 24 hours we get every 4 years. So next time February 29th rolls around, remember it's not just another day. It's a unique quirk of our calendar system, a product of human ingenuity, a cause for celebration, and an opportunity to reflect on our relationship with time. Who knew that an extra day could cause such a stir? So, now we know why February gets an extra day every 4 years. We've taken a journey through time, tracing the origins of leap years back to the ancient Egyptians, who first noticed the discrepancy between the solar year and our calendar year. Their observations led to the introduction of a leap year in the Julian calendar, a tradition that's been carried forward to this very day. We've also looked up to the stars, exploring the astronomical reasons for the leap year. Our Earth doesn't orbit the sun in a neat 365 days. It actually takes about 365¼ days, give or take a few minutes. This fraction of a day might not seem like much, but over time, it adds up. Without the corrective measure of a leap year, our calendar would gradually drift out of sync with the seasons. Then we delved into the mathematics of leap years. Remember the rule? Every year that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100. But these centurial years are leap years if they're divisible by 400. This rule, adopted in the Gregorian Calendar system, helps keep our calendar aligned with the solar year. And we can't forget the societal impact of leap years. From the unique birthdays of leaplings, who only celebrate their actual birth date every 4 years, to the tradition of women proposing to men on February 29th, leap years have woven themselves into the fabric of our lives. In short, the leap year phenomenon is a captivating fusion of history, astronomy, and mathematics, all intertwined with our societal customs. It's a testament to human ingenuity, a solution to a complex problem that combines the precision of science with the adaptability of culture. Leap years, then, are a fascinating blend of history, astronomy, mathematics, and societal norms. Before we wrap up, a question for you. Leap years bring along an extra day, a bonus 24 hours. Have you ever wondered how you would spend this bonus time if it came around every year? Perhaps you'd indulge in a hobby, learn a new skill, or maybe just catch up on some much-needed rest. Share your thoughts. We'd love to hear your creative ideas. Alternatively, do you know of any interesting traditions or folklore associated with leap years from around the world? From ladies proposing to men, to specific foods being eaten, leap years have inspired a myriad of unique customs. If you've got a fun fact to share, don't keep it to yourself. Remember, every day is a gift, even if it's an extra one every 4 years. Until next time, keep exploring, keep learning, and don't forget to follow us for more content like this.